Good evening, everyone, and welcome to the Hibiscus Coast Astronomical Society monthly meeting. For those of you like John, who's on YouTube, you may want to pop onto the Zoom call. Probably just copy and paste the link. That will probably be the best thing. We're going to start off this evening with Josh, who will be giving the news, and then I will move on to the main presentation. So if Josh comes on.
Okay. So yeah, hi everyone. Thanks for tuning in. For those on YouTube. Oh, yeah. Sorry, what's that? Yeah, it's on. Yeah. Is it all working? Okay. Can you see me? Oh, okay. My video's on. Can you see me? Okay. Cool. Yeah. Hi everyone. Yeah. Thanks for bearing with us as we get this sorted out. So yeah, for those on YouTube, you're welcome to watch there. If you would prefer to watch in Zoom, the Zoom description is there. James, I just see a few people in the YouTube comments asking for the passcode as well. Maybe. Yep. And yeah, for those in the Zoom meeting, we do ask that you keep yourself on mute while we're talking. But at the end, when we have questions, if you do have any questions, you can feel free to type them in the chat if you're too nervous to speak up. Or if you'd like to speak up, just unmute yourself and ask your question. And yeah, we can take advantage of the kind of back and forth collaboration that we get in Zoom that we don't get in YouTube. So I'll start us off with the news tonight. I will share my screen, which is this one. Okay. So astronomy news, what's been happening in the sky above us? So some interesting news that's been happening actually just today is the first all-civilian spaceflight has launched successfully. So if you haven't been following this is all about something called the Inspiration 4 space mission. It's very interesting. So this is a private space mission, and it's going to orbit the Earth for 3 days in a SpaceX Dragon spacecraft. So in the last few months, we've had a lot of things happening in the private space area. You know, a couple of months ago, we had Richard Branson's Virgin Galactic. They made their kind of first voyage up into space, followed a few days later by Jeff Bezos's Blue Origin. And in both of those cases, there were it was a mix of civilians and fully qualified astronauts. The thing that's different here, that's very interesting, is this is a first all-civilian space flight. So all 4 of the people in here are just regular people. I mean, they've had training. So they've spent 6 months being trained in how to operate spacecraft and things like that. But these people aren't professional astronauts. So it's quite interesting. So this whole thing is kind of the brainchild of billionaire Jared Isaacman. So he planned and paid for this mission, and it's all about trying to raise funds for St. Jude's Children's Research Hospital, which looks at children's cancer. His aim is to raise $200 million. And you can watch more in the Netflix series Countdown Inspiration 4 Mission to Space. So if you haven't been watching this and you're bored during lockdown and looking for stuff to do, we can certainly recommend it. So James and I watched, there's 4 episodes so far, and the episodes introduce you to Jared. He's this guy here, the billionaire. And we get to follow how they chose the other 3 people to join them on this mission. You get to see them going through the training. And it's really good because you're watching it kind of thinking, how would I react in this situation? You know, if I were on this kind of centrifuge flight thing, as they show in one of the episodes, would I get motion sick, or would I be able to hold it in? So it's really interesting. And the big news, obviously, today is that they actually launched. So there's been a lot of lead up, and they've now launched. And yeah, they're going to orbit the Earth for 3 days. So in terms of the crew, as I mentioned, the commander, Jared Isaacman, he's a tech billionaire. So he made his money with an online payment system called Shift4. And yeah, with all of that money, he decided he wanted to do something interesting, do a kind of private space tourism thing with Spacex. But rather than just take along his friends, he decided to make it a bit interesting and choose regular people to help fundraise. So the pilot is Cyan Proctor, geoscientist. That's her here. The medical officer on board is Haley Arsenault. She works as a physician's assistant at St. Jude's Children's Research Hospital, and she's a child cancer survivor herself. She actually has a prosthetic rod in her leg. So she's now become the very first person to go into space who has a prosthetic. And the mission specialist is Chris Samprosky, data engineer. And I thought I'd just quickly switch to the SpaceX website, because if you are interested in following what's happening, you can go to SpaceX, and I'll just scroll down. And this bit here actually shows where they are at the moment on the globe. So at the moment, they're kind of in the south here, and this is where they're going to head. At the rate that they're flying, they're actually orbiting the Earth around once every 90 minutes. So during the whole 3 days, they're going to circle the Earth quite a few times. This is where they're going to head. I see a few more people joining us. Thanks for joining us. If we could just ask you to put on mute while we're talking, just so we don't hear the background noise. Thanks. So we're just looking at the progress of the Inspiration 4 mission to space. And this is the SpaceX website where you can see the updates. And here's the interesting thing here. So this is showing how high they're flying. So if you recall, a couple of months ago, when we had Virgin Galactic and Blue Origin, Virgin Galactic, the flight got up to a height of, it was just under 100 kilometers. And they were only up there in kind of weightlessness for, I think, about 10 minutes. And then Blue Origin came along and they got above 100 kilometers. And there was a lot of back and forth because there are a lot of different guidelines as to when space starts, but a lot of people consider the boundary of space to be 100. So some people were saying, well, Virgin Galactic didn't really go to space. They got close, but not quite. Whereas Blue Origin, oh, over 100 kilometers. Yeah, they definitely got to space. But meanwhile, here, the Inspiration 4 crew, they're going to a whopping 585 kilometers. So that's higher than the International Space Station and the Hubble Space Telescope. And they're not just going up for 10 minutes and then coming back down. They're actually going to stay in space for 3 days. And while they're in space, they'll be inside this Dragon capsule, which isn't that spacious. And it does have a toilet facility as well. From what I understand, the toilet facilities on the SpaceX Dragon shuttle have never actually been used because all of the manned missions on the shuttle have been quite short. They've just been going to the International Space Station. So all the astronauts who have ridden on this before have kind of thought, well, I'll just hold it in. I don't need to go that badly. But now we're having a mission where these people are in there for 3 days. So I think this will be the first really good test of the toilet system. And the way that the Dragon shuttle is designed, this nose part here, normally this is what docks with the International Space Station. But on this particular shuttle, because they're not docking with the International Space Station, they've removed that dock and they added this glass dome window, which you'll see in the animation. It's, I don't even know how to pronounce this word, cupola or cupola. And apparently the toilet facility is up towards that part of it. So I guess if you're on the shuttle and you go into the toilet, you're probably going to have the best view in the world because you'll be looking out at planet Earth. So yeah, if you are interested to learn more, you can check out the SpaceX website or the documentary on Netflix. So that's the biggest news item this week, but there are a couple of other stories which I've included as well. So the next interesting story, NASA's Perseverance rover on Mars has collected its first rock core sample. And this is important because it's the first time that we've collected a rock core sample from another planet. So it's very big, and it's exciting news for space people and geologists, people interested in what's going on. So the Perseverance rover actually attempted this last month, but it failed. So if they found a rock, they drilled into it, but when the rover kind of retrieved the drill bit, they found it was empty. And so for the last month, NASA's been running a bunch of tests, making sure that the equipment is still working correctly, because they wanted to make sure that, that things are okay. And after all of it, NASA determined that the reason that the first mission failed was probably because the rock was more crumbly than they thought, and it just crumbled into pieces. So they tried again last week, and it was a success. So they now have 2 rock core samples. And from what they can see, the rover has detected that the rock is, I'm not sure how to pronounce it, basaltic, which means it's likely from cooled lava. So at one point there was lava on the surface, which may have cooled, that turned into the rock. And the rover has also detected that it contains salt. And this may have come from evaporated groundwater. So it may have been at a point in time there was water on the ground in Mars, and when that evaporated, it left behind some salt. Of course, we won't know this for sure until we get it back to Earth and we study it. But all in all, we're very excited to have this sample. And yeah, just as things are getting really exciting with taking all these rock samples, NASA's announced that they will pause all work to do with the Perseverance rover and the Ingenuity helicopter for a few weeks, starting in October. You might be wondering, well, why? Why are they putting things on hold? And it's all to do with the Mars solar conjunction. See, the way things work, Earth and Mars rotate around the sun, but because we're going at different speeds, sometimes Mars is really close to us and sometimes it's really far away. And when it's on the other side of the sun, it's hard for us to actually send signals back and forth. The interference of the sun kind of screws up with all of the communication signals. So Mars is going to enter this period in early October, and that's why NASA's announced that during that time, the rover and the helicopter, they're kind of going to go into safe mode for a while. We won't be able to talk to them, and we'll just have to wait a few weeks to see what happens there. And so also the Chinese Space Agency, which also has a rover on Mars, so sorry, a rover or a satellite. So they've also announced that all of their Mars missions will pause for that period as well, because obviously while the solar conjunction is going on, we can't talk to them. But yeah, once Mars comes out around the other side, we'll be able to talk to them again. So also in the news, a mega comet could be the largest that we've ever discovered. So this comet has been named the Dinelli Bernstein comet. I think that's how it's pronounced, after the surnames of the 2 scientists who discovered it. And they found this comet by analyzing images of the sky taken over 6 years. So this was a very impressive sort of sky survey. They took pictures of the dark sky every 2 weeks for 6 years. I think there's thousands and thousands of images in total. And so these 2 guys kind of lined up all the images and overlaid them and wrote an algorithm on the computer that would look for specks that are different between them, but close enough that it's probably the same thing kind of moving across. And they used that to try to detect TNOs, which is trans-Neptunian objects. And so these are objects that are further away from Neptune than us. And so, yeah, so they've ended up finding this mega comet. And at first thought, they've estimated it to be 160 kilometers across, which is really big. So for reference, I think the biggest comet ever is the Hale-Bopp comet, which is estimated to be around 100 kilometers across. But on further research and study, we now think it's probably around 100, not 160. So the reason that we were a bit confused at first is because when we thought it was 160, we thought it was too far away for the ice to be vaporizing. So we kind of saw this spot and we thought, oh, that must be the comet. But some further analysis has shown that it has already started vaporizing. So this kind of big splotch that we see, maybe it means it's actually only this big, but this much is kind of the ice vapor that's coming off it. So that's why the estimate of the size has changed as we learn more about it. Because if you remember, comets are made from ice. That's one of the differences, comets and asteroids. And it's very rare for us to see comets that are that large, because comets obviously kind of swing by the sun and then go out again and, you know, come back like clockwork. But what happens is every time they do that and they come close enough to the sun, the ice keeps vaporizing and more of it melts away, which means over time the comet is going to get smaller and smaller. So the fact that we've discovered a comet that is this big makes us think that maybe this is on its very first journey into the solar system. This could be its first pass towards the sun. And it's estimated that it should approach the sun in 2031. So we've got a lot of time to view it and study it and learn more things from it in the next 10 years as it approaches us. And finally in the news, 2 lucky scientists have won $3 million for developing a more precise clock. You might think, well, that's a bit weird. I mean, we already have clocks. I mean, how much more precise can we get? Yeah, so you may have heard of atomic clocks. And the way an atomic clock works is it measures the quantum leaps in the electrons in energized atoms. So a quantum leap is when an electron kind of jumps from one ring to the other ring. It's a bit weird because quantum leap, oftentimes when we use that word in English, or that term in English, we mean a big advancement. People often say, oh, there's been a quantum leap in our understanding of, you know, space, and they mean a huge leap. But actually, technically, quantum leap means the exact opposite. A quantum leap means the tiniest jump you can possibly make. It's an electron moving from this ring to this ring. And atomic clocks work by measuring those tiny jumps. And atomic clocks are important because we use them for deep space navigation. So when we send out something to space, it can't use GPS like we do here on Earth. You know, here we can always rely on the GPS, the global positioning satellites, to know where we are. But you know, if you're in a space shuttle heading towards the moon, or some sort of probe heading towards Mars, obviously the GPS isn't going to be that good for you. So instead, they'll send a signal back to Earth, which we'll receive, and then we'll kind of check the time and then send it back to the spacecraft itself. And based on the time that's elapsed, that's how we can tell how far away it is, you know, where it's traveling and things like that. So because of that, it's important to have really precise time. The more precise it is, the better that we will be able to navigate through deep space in future. You know, and when we talk about, you know, interplanetary travel, maybe in the future interstellar travel, it's going to be very important for us to have a precise way to keep time. And so these 2 physicists have recently developed a new type of atomic clock that is 1,000 times more precise than the ones that we had before. And this has won them the Breakthrough Prize in Fundamental Physics for 2022. And no, that's not a typo. It's actually the 2022 prize. I don't really understand why they do that, but this particular organization seems to give out their prizes 1 year in advance. So yeah, so the 2022 Breakthrough Prize in Fundamental Physics and $3 million was awarded to these 2 scientists. And this new type of clock that they've developed, it's estimated that if this clock operated for 30 billion years, which is more than twice the age of the universe, it would probably lose 1 second. That's how accurate it is. And that's it for the news this evening. So I'll now pass back to James for our main presentation. I'll stop sharing. And over to you, James.
Okay. things sorted here so I can see what's going on. Okay, I think we are almost there. Move that up a little bit. Okay. I think we are ready to go. So yes, welcome everyone, as I said earlier, with most of us who are still in lockdown. I hope it's not been too much of a drain on you, sort of mentally and physically. I know I've just started a new job this week, so it's been quite an interesting experience, especially that I have to work from home. But there we go. This evening we're going to be talking about a universe of weirdness. And we're going to be having a look at some of the weird and bizarre and mysterious things that we can find right on our doorstep all the way to the furthest edges of our universe. First one we're going to have a look at is this one, which is called Hogue's object. And you can see it's a really pretty looking thing. So it was discovered in 1950 by Arthur Hogue, who wasn't quite sure what it was the first time he discovered it. So he discovered that this is quite a big object. It's 600 million light years away, and it's about 120,000 light years wide. So this thing is a really, really massive, massive object. But it doesn't look quite like anything we know. And the closest things on that scale would be a galaxy. Originally, he thought that this was some sort of planetary nebula, or something along those lines, because, you know, if you have a look in the middle, there is a nice big starry looking thing, and then on the outside is this what looks like gas. Well, in fact, yeah, he couldn't have been more wrong. It was actually a galaxy, and yeah, very unique kind of thing. So was it a planetary nebula? No, it was because it's just too big. Could it be an Einstein ring? Was another thing. Perfect Einstein ring, where the gravitational lensing takes place. So there's a galaxy behind a big star, and due to the gravitational lensing, it creates that lenticular effect around it. But it was quickly determined that it can't possibly be what it is. And of course, as I mentioned, it became a galaxy. And if you have a look there, you can see it's got a whole lot of stars in the middle, like nice orangey stars. Then there's a bit of a gap around it, and then kind of another circle around that with all sorts of other stars in it. But that's quite amazing. But there's even more weirdness that goes on. If you have a look inside Hogue's object, there's another one just there. Another one where it's nice and bright in the middle with a nice ring around it and nothing in the middle. So beyond its bizarre appearance, the real mystery is how this kind of configuration could have arisen. So all these things, people discussed and then rejected, discussed and rejected. So what actually caused this? Again, no one really knows. But some people think that it resulted from a small galaxy which passed through a larger one, like a cannonball, about 2 to 3 billion years ago. But the lack of any candidates in the vicinity and the slow spin of the core basically discounts that as a theory. One scientist thinks that it's a barred galaxy which went through some extreme instability at some point in the past, and that's what happened with the shape. But others point out that if that was the case, then the nucleus would be disc-shaped rather than a ball, kind of like a globular cluster in the middle. So nothing really works. There are another, as you can see, there's another very rare one right there in Hogue's object. It's kind of a mini Hogue's object. We have found a couple of other galaxies kind of like this, but they all have like some differences where there's some sort of trace of a spiral structure, or the nucleus has a bar or an elliptical or disc shape. So this Hogue's object is very, very unique in the cosmos, and the little one in the middle is probably even more unique that we see that in the middle of this one. As if to tease us further, nature has a final surprise. Of course, where these things are found, like I say, very, very rarely. When they went and they had a look at that little one in the middle, they discovered, in fact, it is exactly the same as this Hogue's object. So what is the chances of a Hogue's object appearing inside the Hogue's object? Very, very weird. The next one that you might not have heard of is the Hexagon on Saturn. So, long time ago, 2006, seems like a lifetime away once you're in lockdown, Cassini went past Saturn and took photos, and this is one of the photos showing this hexagon-shaped object right up on the top. Now, what is interesting is that the way Jupiter is positioned with the Earth, you can never actually see this object with a telescope, even a very powerful telescope. You'll just never see this thing. You can only see it with a spacecraft once it's gone past. So what can cause this thing? Well, people have been speculating for a while. They went back into the past. They thought, oh, maybe it's one of these aberrations. Just Cassini in the right place at the right time. But of course, they went back into the old Voyager photos, and they discovered it was actually in the old Voyager photos, and that people didn't actually notice it at the time. So this thing is actually quite a big thing. Its sides are about 13,800 kilometers long. That's on each little side. And it's about 24,000 kilometers across. And it extends to about 100 kilometers below the cloud layer. So very, very strange thing. Also, surrounding it in that little sort of band are winds that go up to 500 kilometers per hour. That's really, really strange, but it gets even stranger because this thing rotates every 10 hours and 39 minutes. So not only is it buffeted by these winds, it rotates and it keeps its shape. So what on earth could this thing be? So one of the things is that it could be a standing wave. So this is when you get a couple of waves that go into sync, and it forms a wave which just stands there. The problem, of course, is explaining why a standing wave would assume this kind of shape, or any geometric shape for that matter, because we've never seen that before, and fluid dynamics has been quite well studied here on Earth. Another thought is that it may result from a unique, previously unseen type of aurora. Maybe this is an electrical thing. But, it rotates in sync with Saturn's radio emissions. So maybe it could be that. But, again, we don't think it really could be. Of course, not surprisingly, those into UFOs have their own explanation. And they say it's an alien structure that's been put there. But why would it be put there facing away from Earth, for a start? You'd think they'd be observing Earth. And what is the purpose of it? You know, is it like some big city? Who knows? I somehow doubt it. So in the spring of 2010, some Oxford University researchers who study fluid dynamics decided to test out a couple of scenarios with this, and they produced kind of similar-ish looking thing by having two things rotating at the same time. So they had a tank of water which rotated around on a table, and then inside they had another thing which rotated at a different speed. And this seemed to produce something similar to the six-sided pattern in this glycol water mixture. But does it prove that this is the reason for Saturn's hexagon? No, it doesn't. It's probably a starting point from where we should be looking. But, you know, this is something that we need to keep an eye on in the future, and the only way we can do that is through spacecraft. So the next one is the Black-Eyed Galaxy. Now this is quite an interesting object, firstly because it's the only celestial object that is named for an injury. So Chris might like this one, because it kind of looks like someone's been got a nice big black eye. So it was originally discovered by the English astronomer Edward Pigott in 1779. And so it's been known for quite a long time, this particular one. Some people also call it the Sleeping Beauty Galaxy, but it's not really called that much anymore. I think people much prefer the name Black Eye Galaxy. So what is it made up of? It's actually made up of huge complex clouds of carbon particles. So that's all that dark stuff that we can see. So these carbon particles, actually it's a bit more complicated. They're full of the basic building blocks of life as well. So quite an interesting thing, but it gets even more interesting, as with most of these, because it has counter-rotating segments. So if you have a look at that part of the galaxy, you'll see that it moves clockwise, whereas this part of the galaxy moves anti-clockwise. So how on earth does something like that happen? Because if you've been following Chris's talks, that's not what's meant to happen. They're all meant to move in the same direction, but this one moves two totally different directions. So the inner 3,000 light-year radius spins clockwise, and the outer 40,000 light years goes into the other direction. So one explanation is that sometime in the past, probably a billion years or so ago, M64 collided with and gobbled up another galaxy. And as these two galaxies merged into one, they still had, you know, sort of enough power to keep their motions in play. And of course this has gone to the present day. And the shearing zone where the two opposing segments rub against each other results in a very turbulent battleground, you could call it, where there's lots of nebula knots and new star production. So what, you know, where did this come from? Possibly from there, we would say. There's not a lot of evidence for it, but you know, it would be quite nice if we could sort of discover a little bit more about it. So next up, we're sticking with ones which we know. Oh, sorry, I don't know why it's doing that. There we go. Amigo Centauri. So for anyone in the Hibiscus Coast Astronomical Society, if you ask them, what is my favorite object in the sky? That's the one, the Amigo Centauri. I love this thing because you can see it with your naked eye if you are in a dark enough spot. So Amigo Centauri floats at a distance of about 15,800 light years from Earth, and it was listed long ago by Ptolemy in about 2,000 odd years ago, where it came up, where it was written about in ancient Egyptian texts. And it's got a number of weirdness things around it. If you remember from Chris's talk on globular clusters last time, he was saying that globular clusters are quite unique. They all in a ball, they all tend to be the same age, so we can study them as there's so many stars, they're all roughly about the same age. Of course, this makes Amigo Centauri quite different because the stars in Amigo Centauri are all different ages. So not only are they different ages, they look, some of them look different. So you get some big red giants, you've got all the dwarves. It's just amazing sort of what you can find in Amigo Centauri. And this goes against everything that we know about globular clusters. There's another weirdness as well about this particular globular cluster, and that is that it's got about 5 million stars in it. Now, the average globular cluster has only got about 100,000 to about 700,000 stars in it. So this is a massive scale at 5 million. In fact, it's so large that, you know, like I say, it's about the size of the full moon in the night sky. Just very dim, so that's why we don't notice it. So in the center of this as well, the suns crowd so closely together that they sit just 1/10 of a light year apart. So this is the distance between the Earth and the Sun times about 6,000. So pretty close. Another weirdness with this one is that other star clusters have no cohesive spin to them, but Amigo Centauri rotates, and its fastest stars are moving at about 21 kilometers a second. So why should this star cluster be so unique? And why has it been so well studied over the past, particularly 45 years? In 1999, a Korean team of astronomers studied Amigo Centauri, and they studied over about 50,000 of the individual stars. And they found that unlike every other cluster, it shows stars from a spectrum of metallicities. So these are all elements which are heavier than helium. And it indicates that this formation must have been happening over billions of years, not all at once, which is what a globular cluster is. But if it's happening over billions of years, we are talking about what? A galaxy. Is this a galaxy? It's quite a strange thing. So one of the leading thoughts on this is that one of the weirdest things about this is that it is possibly the remains of a galaxy that collided with the Milky Way billions of years in the past. So it was drawn in, it was merged and assimilated and broken apart, and that was left was the nucleus of this galaxy. And that was the only thing that was left as the rest of the stars moved off or were absorbed by the Milky Way. So Amigo Centauri is more than just huge and glorious. It actually possibly came from somewhere else. It's possibly another galaxy, or the core of an old galaxy. So next time you're out and you have a look up at Amigo Centauri, Is it a globular cluster or is it a galaxy? I'll leave it up to you. The next one are pulsar planets. So particularly we're having a look at this one. It's called PSR B1257 plus 12. And it lies in the constellation of Virgo at a distance of about 980 light years away. And as a pulsar, it spins at about 161 times a second. And of course, like all pulsars, it is also a neutron star. So if you remember back at Chris's talks about how stars die, you find that these were once nice big red giants, and they collapsed down, and bang, they blew off all their outer layers and left this little core that was so compact and spinning really, really fast. But quite an amazing thing happened in 1992, because they discovered that there were 2 planets around this particular pulsar. Now, this raises a lot of problems because, if a pulsar neutron star has resulted from a big massive nova, all the planets near it should have been disintegrated, just wiped out of existence. But yet here are 2 planets. By the way, these are the 2 planets are actually the very first planets found beyond our solar system. Some people say they're not, that other planets were discovered, but those were actually discovered about 2 years later, just as a side interest. So they've really been studying this whole system, and they actually discovered that there's a 3rd planet confirmed, and possibly even a very small 4th one. So 4 planets around a pulsar neutron star, this just does not make sense. So what could cause such a thing? Well, a couple of people have suggested that possibly before the star went supernova, that there were a couple of Jupiter-sized planets around it. And of course, when the pulsar exploded, it wiped out all that gas that was around those planets. But those planets all had kind of a rocky core, which somehow survived. And but is it possible? Can you survive a supernova blast? It's just hard to imagine why. So, it's quite interesting because in the year 2000, astronomers found another pulsar in the Scorpius constellation, and it's sitting in the M4 globular cluster near Antares. And when they had a look there, it was also an even more bizarre system because it consists of 2 collapsed stars in a tight orbit, a pulsar which is only about 26 kilometers wide, and then a white dwarf about the size of the Earth that circle around each other. But around those 2 stars, they discovered that there's a planet as well. So there's 2 stars which have wreaked untold destruction in this area, but yet there is this planet, and this planet's about they say it's about a century for it to go around on the thing. But that's it's quite amazing. We would probably never be able to go there because these pulsars deliver sort of X-rays and gamma rays and all sorts of other radiation. But it's just amazing that these planets actually exist around pulsars. So the next weird one we're going to talk about is here in our own backyard. the Milky Way Center. Now, the Milky Way Center has actually got two very bizarre things. So the very first weird thing is that it contains an antimatter fountain. So when this was observed, this is back in 1997, they were having a look for positron streams around in the universe. And they discovered that actually there's this huge positronic stream that's emanating from the galactic center. So when they took a bit of a look at this area, they discovered that in fact there was a whole fountain of antimatter that was being produced. Now, antimatter has the same appearance and behavior as ordinary matter. So an antimatter sun will look just like our normal one. And even spectroscopic analysis couldn't really tell them apart. But if an antimatter object touches anything made of conventional matter, both of them would just obliterate each other in a very, very violent way. So, when we look up in the night sky, there's actually no way of really telling which is matter and antimatter terribly much. The only way we can tell is that the explosive contact between the matter and the antimatter produces gamma rays with a very distinct signature, and that's what we are discovering here. So what could be creating them? The black hole that's sitting there is probably the very first one to kind of look at, but our black hole is actually very strangely quiet. So it's very hard for us also to have a look there and see what's going on. So where is this antimatter factory? Where is the source? Is there another black hole lurking around which is producing antimatter? Scientists have also looked at the other usual suspects, and they've eliminated pulsars, quasars, star-forming clusters, satellite galaxies, cannibalized satellite galaxies. They also crossed off massive stars and cosmic ray interactions. So no one knows where this thing comes from. No one actually has a clue. Which brings us to the next one, is the weird Fermi bubbles. So if we have a look again, here's the Milky Way. We see that above and below the Milky Way on the plane, there are two massive bubbles. Now these massive bubbles are also can't really be explained. The temperature is somewhere in the 3.9 million degrees Celsius, and it is kind of unknown as to why it should be there. We've got that black hole that's there. The cosmic rays are emanating sort of out of that area, but no one knows why. Could these two things be linked? Could the antimatter fountain be linked to the Fermi bubbles? No one really knows why this is the way it is. So the ultimate question might even be stranger. Could this be more evidence of dark matter? Could dark matter be meeting its opposite entity in total annihilation? So kind of the same way that matter and antimatter mix. Would this be the equivalent of dark matter and dark antimatter? Probably something a lot different to this, but at this stage, according to astronomers, it just confuses everything. So a lot more study is needed there. But this is quite amazing because this is our Milky Way galaxy doing all this weirdness. So kind of closely related in topic, though, is this galaxy called Segway 1. Now, if you have a look there, you'd say, but that's not a galaxy, it's a couple of stars. So the one on the left is from one telescope, one on the right is from another telescope. And you would be quite correct. There are very, very few stars, but it's a galaxy nonetheless. It was discovered in 2006 from the Sloan Digital Sky Survey, and it is a survey which was particularly looking at Milky Way dwarf companion galaxies. And during this sort of year 2006, they discovered 12 of these companion galaxies. Of course, we have two of them down here, being the Large and Small Magellanic Cloud, and there are one or two others. But this actually brought the total up to 24. So there's 24 dwarf companion galaxies going around our Milky Way. This one, Segway 1, is about 75,000 light years away. It's in the constellation of Leo, and it's about 1 billion times fainter than our galaxy, which is why you can't really see it. But they are very, very faint, very, very faint indeed, and they're spheroidal galaxies. But Segway 1 is quite a strange thing, because when they went and took a guess at how heavy is this galaxy, they discovered something amazing. Most of these dwarf galaxies, like the Magellanic Clouds, we can calculate how heavy they are in terms of how many stars there are. We can go and have a look, and also the way gravity affects it. Some of them are slightly wrong because we can't see very clearly all the way to the other side, or there could be dust blocking the view. So the most we've been out is about 6 to 8 times more massive than it appears. But here's where Segway 1 is different. It is thousands of times more massive than what we would anticipate it is. So it weighs around 600,000 suns, but it only emits light of just 300 suns, which is kind of weird. But it makes it 1,000 times more massive than what it actually appears. So it brings up a question: is like, if there are so few stars there, where does all this mass come from? Where does its weight come from? So after a lot of thinking about this, they actually discovered that this particular little galaxy has no significant hydrogen gas, so there's no nebula. There's no dust there because there's nothing blocking the light, and there's no central black hole, which is quite common with most of these galaxies. So it left one thing. Segway 1 is the first and only dark matter galaxy in the known universe. How's that for? So, much like the wind, we can look out and see the wind blowing in the trees. We can't actually see the wind. In this case, it's the same sort of thing. We look up into space. We can't see dark matter, but we can see the effects of it. And this is the very first dark matter galaxy that we are pretty convinced is real dark matter, because it's the only thing which will fit with what we are seeing in this area. So it's not quite as rare as we think it is, because there's this other one called Galaxy Cluster Able 1689. Now, this galaxy is about the same size as Segway 1, but as you can see, a lot more in the ways of stars. But if you look closely at this picture, you will see a couple of interesting things. It also is 1,000 times more massive than it appears, but it also bends and magnifies light. So if we have a look like here, you see it's like a bit of a, where it's been stretched, the light's been stretched. And there again, we can see it again. In fact, all the way around. And then if you have a look over here, it's like a, a nice little circle. So straight off, people think, okay, so there must be, this must be an Einstein ring. Those must be galaxies, behind it, or stars behind it, and the gravity, and has caused it to do this. But it's not massive enough to actually do it. You need something pretty big to do it. So they have said that the only thing that could create that mass is dark matter. So dark matter and gravity are responsible for the stretching out of the stars and the light and the bending of the light. So those are two galaxy clusters which are out there, which are actually proving that dark matter actually exists. So moving on a little bit closer to home, you have a look at Iapetus, particularly at the equatorial ridge. So if you have a look at this picture, you'll see quite clearly that there is a nice little ring all the way around it along its equator. And that's a real ring. It's like a mountain. It's about 200 kilometers long. It goes all the way around this little moon. It's about 20 kilometers high, and it follows the equator almost perfectly. So this is another discovery from Cassini. But Cassini went and visited quite a number of other places, and of course around Saturn, where Iapetus is, in case you didn't know, there are some other moons. So Atlas and Pan definitely have it, an equatorial ring as well, and also Daphnis has possibly got it, although it hasn't really been confirmed yet. So what has actually caused these rings around the equator? One thing could be, one theory is that all these moons had a ring around it, kind of like Saturn. So how beautiful Saturn is with the ring system around it. They say that possibly these little moons also had a ring system around it at one stage. But over time, what has happened is that because there's not been enough momentum to keep the ring system in place, they've slowly come in and they've collapsed in on itself. The problem is that it would mean that the ring collapsed in beautifully, that it had to come in exactly correctly all at once. You'd expect that if something like that happened, it would be a bit more jagged and catastrophic looking, not like that. So possibly not that. Another theory is that it's icy material from below the surface which has forced its way up. But why would it do it in a nice ring around these moons? No one knows. Third theory says rotational spin. So they say back when these moons were still forming and were very hot, they spun quite fast, and what happened is that it started to bulge out along the equator, and as it cooled, it kind of left that ridge there. Quite a weird thing, but no one has been able to guess why this band is almost perfectly coincidental with the equator. So this is one of the mysteries of our solar system. Another final oddity of Iapetus is its orbit. Although it's quite a substantial moon, it does not orbit around Saturn's equator and ring plane like all the others do. So it has a bit of an inclination. Because of the inclination, it's the only large moon around Saturn, which would offer a really good view of the planet's rings. All the others would see the rings edge on, so you wouldn't really see it. Much like we see with our Milky Way. We just see the edge. But because of the inclination, the Iapetus, you'd be able to see the rings and really pretty. So, bit of a strange one, Iapetus. And because of its orbit, it makes it really hard for spacecraft to actually go and visit it, because most of the time they're visiting Saturn and the moons that are on that plane. So there has not been any plans to visit it as of yet, but apparently in the far distance they are planning on things like that. Next up is the Red Rectangle Nebula. So astronomers call this nebula's sort of alien illumination. It's called the Extended Red Emission, or ERE. It was first discovered in 1975, and they called it the Red Rectangle for obvious reasons. Since then, it has been observed in other places and other galaxies as well, but this mystery has been around for about 30 odd years now. The odd glow as well is associated with dust that's made in ultraviolet light, and the problem is that there's also a huge amount of what's called polycyclic aromatic hydrocarbons around this particular area. Now, these carbon and aromatic hydrocarbons react with ultraviolet and basically get destroyed. So there must be something really going on here. So the guesses on this one is that this binary stars which are sort of orbiting around each other, they produce spherical gas ejections on each side, and then as things take place, it produces shock waves, which kind of cause that kind of effect. But it doesn't really work well, and of course, like I say, the color is a bit wrong, and also these aromatic hydrocarbons shouldn't be there with all of this going on. So what they think is that there is possibly some dust that's surrounding these stars in the middle, this binary system in the middle, and this dust is shielding the rest of the structure from the ultraviolet radiation. So basically it's the light, visible light that's coming through, leaving the UV light behind, and this is what's preserving the hydrocarbons, and this is why the look of this is red and not blue like we would kind of expect. So in 1981, Vincent Ike, who's a Dutch astronomer, he's worked quite a lot of these, particularly looking at you know, the spherical gas injection and sort of how it all works. And he actually worked it out. He said that we are possibly looking at sort of two ice cream cone shapes which are meeting in the middle, and we are just looking at it edgewise, which is what creates what looks like a giant X. One of the other interesting things about this thing is that it's also protoplanetary, and because of these aromatic hydrocarbons, there's a very good mix for life up there. So who knows what we will discover when we actually get to this place and have a look a bit closer at it. Next up is the galaxy cluster CLG J0212, blah, blah, blah. So why is this particular galaxy so interesting? Well, CLG, as we'll call it, is comprised of about 60 galaxies, including several colossal, intensely red galaxies at the center. You can see those red dots there. Those are those galaxies. Now, here is the problem, and it's a bit of a mind bender, so you'll kind of have to get your head around this. These galaxies are very, very, very far away. So they have very high redshift, and they've proven that this light left 9.6 billion years ago. So this is in the first few billion years of the formation of the universe after the Big Bang. So when we have the Big Bang, it occurs, these are the ones that are right on the edge. Now, when we look back in time, 9.6 billion years, we're looking at these galaxies of what they looked like then, not what they look like now. So although they are 9.6 billion years old, we are looking at them as if they were quite new. And if these galaxies are new, there's a number of problems with this particular CLG galaxy. So massive galaxies of ancient red stars should not exist in the early universe. It's just one of those things that's impossible. Chris actually spoke about this quite some time ago, about these galaxies in the far edges of the universe. Basically, they've got no time to gravitationally attract and join with other galaxies. So newborn stars should always give these like little spiral galaxies very blue luminescence. So there should be a lot of blue new stars there. There shouldn't be these red stars. So what the hell is going on? This doesn't make sense. How can there be these old red stars in an area where there should only be young blue stars? So this has been confirmed with NASA's infrared Spitzer telescope, as well as Carnegie Institute's 6.5 meter Magellan telescope in Chile. Both came up with the same age, so it definitely is old. There's a few choices of theories that we could have a look at. The most common theory is one which actually says that the Big Bang didn't happen. So it says the universe is not infinite, it's finite. And the CLG actually proves this. Now what that means is that the Big Bang never happened, that kind of everything was all there anyway, all this gas was already in the universe and came together and clumped together and formed galaxies and whatnot, at roughly around the same time, which will mean we have old red stars around near us, so therefore there will be old red stars there. We have youthful stars, there should be youthful stars, and this is exactly what we're seeing. However, these are redshifted, which means that they are traveling away from us at a massive speed and have been for a long time. So it's kind of a bit of a conundrum, because as Casey Popovich of Texas A&M Department of Physics and Astronomy said, it's like if we dug in an archaeological site in Rome and found pieces of modern Europe in amongst the ruins. Or as someone else put it, if we dug underneath the pyramids and discovered a Mercedes-Benz fully intact. What it is, how it works, I have no idea. No one else seems to know either, but it goes totally against everything that we know about science. So there we go. We have gone and had a look at weirdness within our own galaxy, on our doorstep, within our Milky Way, and now out towards the furthest reaches of the known universe. So thank you all. If you would like to ask questions, you can unmute yourself if you're on Zoom. And let me stop sharing there. Okay. Okay, are there any questions? You can also, I see there's something in the chat there. Let me open it up. Okay, I'm going to just pop on the headphones because I need to make a slight adjustment here. Okay. If there are no questions, sorry, Peripi, I've kind of missed you there on YouTube. Yeah, sorry about that. Yeah, so Chris, do you want to pop your video up again? And just unmute yourself.
Yep, all good.
Excellent. Okay. Right, last call for any questions. I don't think so. Yeah, so it's quite amazing, Chris, you know, how much of this actually goes back to all those basic principles that you've sort of taught us, and how there are examples of where it just doesn't work.
Exactly. I think we've still got a lot to learn. There's a lot of hidden messages in there as well. But that's good. It's good because it's any topic you pick out in astronomy, it's a good opportunity just to go over all the basic principles and what works and what doesn't. So that covered a good range of those, James.
I always say, you know, it's kind of like with everything, even with I suppose medicine. You know, I give you an aspirin, you fine. I give Josh an aspirin, he's fine. I take an aspirin, I'm fine. I give someone else an aspirin, they have an allergic reaction. You know, and why they have that, sometimes we really don't know. You know, and I think with all of science, there's always something that is thrown in there which makes us question our knowledge, which I think is a really good thing. Because that's the way discoveries are made and how our knowledge expands, is our thirst for trying to find the answers to those things.
And we're certainly living in very interesting times with new telescopes coming online all the time.
Oh, yeah.
Generations of telescopes. We're living in very exciting times. The amount of information that's been uncovered is just great. I think James Webb's due to be launched on the 18th of December. That'll be looking into the sort of far infrared, which you touched upon with distant galaxies and the very first stars and galaxies.
I'm really looking forward to see what that's going to be looking at, because, you know, as you mentioned, you know, there's quite a lot out there, which I think this telescope will help, particularly with that final one with those faraway galaxies being all mixed up and having all different, you know, really old stars in it. I'm also very keen to see what it will discover about those two dwarf galaxies with the dark matter. Is it actually dark matter, or will they suddenly discover it was actually something else?
It will be dark matter, James. A brave person who stands up and says there's no such thing as dark matter.
We won't talk about people who told the Catholic Church that the Earth was round, and we weren't the center of the universe.
So in 2 weeks' time, the next one will be online. Actually, be in 3 weeks.
3 weeks. 3 weeks time.
So I'm going to be talking on Mars. Mars, as you know, current conditions of it's very dry, low atmospheric pressure, very cold, but you know there's some early evidence that there was liquid water on its surface. So you've got to ask yourself, has Mars always been cold, dry, and thin atmosphere? The short answer is no, it hasn't. So I'm going to have some fun explaining to you all the evidence that clearly shows liquid water flowed on its surface, without a doubt. And then we'll talk about the most likely scenario of what Mars was once like and why it is and why it's changed. So it's an important thing to study so we can understand the sort of the changes that are occurring on Earth.
One other thing, by the way, with the Inspiration 4, if you go to the Facebook group, I did a post earlier this evening, and it will show you the times that you can go out and actually watch it pass over us. So hopefully the weather clears up in the next couple of days. We could actually get out and go and see it. So that is there. It will probably change as their orbit changes. So just keep an eye out on that particular site, and it will keep updating as things progress. But thank you everyone for joining us. Hopefully it's not too long before we are back in person again, and have a good evening.